Welcome to Lesson 6, which is all about modifier fundamentals. Today, we'll examine some of the most important modifiers, tools that give us incredible flexibility when modeling. Before we go deeper into specific modifiers, we first need to understand the modifier stack, because this is the foundation behind how all modifiers work in 3ds Max. Imagine the modifier stack like a vertical list of layers. Every time you apply a modifier to your object, like Turbo Smooth or Shell, it gets added to the top of this stack. Each layer changes how the model behaves or looks, but your original shape underneath stays untouched. That's what makes the stack non-destructive. Let's take a simple example. You have a low poly model, and you apply a Shell modifier to give it thickness. Then on top of that, you add a Turbo Smooth modifier to smooth everything out. If later you decide to change the thickness, you just go back to the shell layer, adjust the values, and Turbo Smooth will update automatically based on that. Now, here's the key point. The order of modifiers matters. If you switch the order and put Turbo Smooth before shell, the result will be completely different. You'll smooth the original low poly shape before it has any thickness, and that might not be what you want. So always think about which modifier should come first, based on the result you're after. You can reorder modifiers just by dragging them up or down in the stack. But be careful. Not every modifier likes being moved around, and sometimes that can cause unexpected results or errors. There's also something called collapsing the stack. That means turning everything into a single editable object. It can be helpful if you're done making changes or want to simplify things, but once collapsed, you lose access to the individual modifier layers. So only do it when you're sure. You can also simply right-click the object and convert it to an editable poly. In both cases, all the modifiers are baked into the geometry, and you're left with a single editable poly. To sum up, the modifier stack gives you freedom to experiment, go back, and make changes without ruining your whole model. Understanding how it works is essential for using modifiers properly and modeling efficiently in 3ds Max. Let's start by creating a box with specific parameters. Set the length and width to 800 centimeters and the height to 2,400 centimeters. For the segments, set 10 segments for both the length and width and 36 segments for the height. Now we're ready to start applying modifiers and building up our modifier stack gradually. The first one we'll apply is the stretch modifier. It is a simple tool that helps you stretch or squash your object along an axis. It's great for creating objects that need to be elongated or compressed, such as ropes or rubber bands. By applying the stretch modifier, you can quickly change the proportions of your model along a particular axis without manually adjusting the geometry. Set the stretch value to 1 and make sure the z-axis is selected. Next will be the twist modifier. It applies a rotational deformation to your object. This is ideal for creating twisted shapes, such as screws, ropes, or spirals. By controlling the angle and axis of the twist, you can add dynamic, organic-looking features to your models with just a few adjustments. Set the twist angle to 130 degrees. The taper modifier allows you to gradually alter the proportions of your object along an axis. It's useful for creating shapes that start wide and narrow down, like cones or pyramids, or vice versa. You can control the direction of the taper, adjusting how the object thins or thickens along the axis. This modifier is ideal for modeling tapered structures with ease, such as vases or certain architectural elements. Set taper amount to -0.7 and curve to 7. The lattice modifier transforms your model into a kind of framework by turning edges into struts and the vertices into joints or nodes. It's super useful for creating sci-fi elements, mechanical frameworks, or anything that looks like it's made out of tubes or bars. When you apply the lattice modifier, it replaces all the edges of the model with cylinders. You can control the thickness of those cylinders and how detailed they are. You can also choose to show just the struts, just the joints, or both. One great use case is creating a sci-fi cage or grid-like design. Set the strut's radius to 4 centimeters, the segments count to 1, the sides count to 15, and enable smoothing. Set the joint radius to 8 centimeters, segments to 10, and make sure smoothing is enabled as well. The bend modifier allows you to bend your object along an axis. It's commonly used for things like pipes, arc, or any model that needs a curve. You can control the angle and the axis of bending, whether it's along the X, Y, or Z axis. This modifier is especially useful when creating curved structures without manually adjusting every vertex. Set the bend amount to 180 degrees. With these modifiers, we've created a futuristic, monumental form. We used stretching, twisting, tapering, and others. This group of modifiers allows us to generate a wide range of shapes and dynamic structures. Now, for the final tweaking stage, let's explore one more important modifier, the FFD modifier. It comes in different configurations like FFD 2x2, 3x3, 4x4, etc. And it's a powerful tool for bending and stretching your model more freely. The FFD modifier adds a control lattice around your object, allowing you to move the lattice points to deform the object inside. To gain control over the lattice joints, just click on the FFD modifier in the stack to activate it. Then adjust the control points and tweak the shape. Once you're happy with the result, simply deactivate the modifier and the changes will stay. This gives you complete control over the shape, making it great for organic modeling or when you need complex deformations without affecting the underlying mesh too much. Next, one of the most common and powerful tools for modeling is the symmetry modifier. It allows you to build just one side of an object and then automatically mirrors it across an axis. This means you only have to do half the work, while still ending up with a perfectly symmetrical result. Let's create a small dumbbell as an example. Start by making a box with a length of 8 centimeters and a width and height of 10 centimeters. Delete one polygon from the side, then select the open edge and using the Shift plus drag method, extrude it to build the inner shape of the dumbbell. Next, let's add some supporting edges around the corners where we want to keep the shape a bit sharper after applying Turbo Smooth. Once that's done, apply the Turbo Smooth modifier and finally, add a symmetry modifier on top. Activate the symmetry modifier and try dragging the mirror axis in the viewport. You'll see that the symmetry is working, but the direction might need some adjusting. In our case, we want symmetry along the y-axis. So let's turn off the x-axis and enable y instead. Now, drag the y-axis to fit the mirrored part. You can also flip the axis direction if needed using the flip option. Let's talk about Boolean operations, a set of tools that let you subtract objects from each other to create complex shapes. In older versions of 3ds Max, Boolean operations were available as part of the compound object section. While that method still works, it has largely been replaced by a more modern and flexible approach. The Boolean modifier, introduced in Max 2024. It allows you to stack and manage Boolean operations directly in the modifier list. This makes your workflow non-destructive and easier to tweak at any time. You can add, subtract, intersect, or merge objects, all while keeping full control over the inputs. Let's create a quick example to demonstrate a Boolean cutout using text. First, create a wall using a simple box object. Set its dimensions so it looks like a vertical panel. Go to the Shapes section under the Create panel and choose Text. From the front view, click and place your text spline in front of the wall. In the modifier panel, type in your custom text, anything you like, such as Excite or your name. Now we need to give the text some volume. Apply a shell modifier to give it thickness. Around 30 centimeters will work well. Make sure the text thickness is greater than the walls, so it cuts through completely. Once your text has depth, move it so that it fully intersects the wall from front to back. Then select the wall, apply a Boolean modifier from the list, choose Subtract, and click the text model in the viewport. The text will now be cleanly cut out from the wall. After performing Boolean operations, it's always a good idea to check the geometry. You might need to clean up extra edges or convert the result to an editable poly for final tweaks. Also, it is not necessary for one object to pass through the other to perform a Boolean operation. It cuts exactly in the places where the two objects touch each other. There are two modifiers left to cover. One of them is the noise modifier. It introduces random movement to the vertices of your object. You can control how much noise happens in each direction, X, Y, or Z, and also whether the noise looks smooth or more chaotic. This is perfect for breaking up flat, boring surfaces and making things look more natural. For example, let's create a plane with a size of 500 centimeters by 500 centimeters. Increase the length and width segments to 100 to give us enough geometry for deformation. Now apply the noise modifier and raise the z-axis strength to 10 to create vertical displacement. You can also adjust the noise scale to control how large or small the deformations appear. This gives you full creative control over the surface detail. It instantly becomes an uneven, wavy surface, which is great for terrain bases or stone-like materials. Or if you're working on a sci-fi panel and you want it to look slightly worn or imperfect, a subtle noise effect can add just the right touch. The second one is the sweep modifier. The sweep modifier is a powerful tool that allows you to quickly turn 2D splines into full 3D geometry. Imagine drawing a simple line or curve, and then instantly generating something like a pipe, cable, handrail, or even a baseboard. That's exactly what sweep can do. It works by sweeping a profile shape along a spline. These profiles can be chosen from a list of built-in presets, like rectangles or I-beams, or you can use your custom shape. Now let's create a crown molding profile using a line from the front view. We don't need to perfect the shape right now. This is just for demonstration purposes. Use corner rounding to soften the angles if needed. Next, we'll create the main line that will later turn into our crown molding. Once your shape is ready, apply the sweep modifier. As soon as you do that, you'll notice the line now has volume. It becomes a 3D object. Next, we want to specify exactly what shape the sweep should follow. In the section type rollout, check the option that says Use Custom Section, then click the Pick button, and select the molding profile you just created directly from the viewport. And that's it. Your custom crown molding is now complete. And the best part? It's fully non-destructive, so you can keep editing the original spline or profile shape at any time. This modifier is especially useful in architectural modeling or when you need repeating shapes along a path. For example, wires wrapping around an object, or metallic trims on a sci-fi panel. In short, Sweep takes something simple and makes it work fast, perfect for clean, repeatable designs. All right, that brings us to the end of Lesson 6. Today, we explored the power of the modifier stack and learned how different modifiers can completely transform a basic object into something dynamic and visually striking. From stretch and twist to FFD and Boolean operations, we saw how modifiers give us the flexibility to create both mechanical and organic forms. We also covered the symmetry and sweep modifiers, both of which can save you tons of time and open up creative possibilities. Remember, modifiers are all about working non-destructively and staying flexible. The more comfortable you get with stacking, tweaking, and combining them, the more control you'll have over your modeling workflow. It gave you a solid foundation for working with modifiers in your projects.